Okay, so in this video, we're going to be talking about the ambiguous case of sines and how to apply the law of sines when you have a triangle that is side-side angle. Now, I already did a video on the law of sines dealing with angle, side, angle, and angle, angle, side. But when you have side-side angle, you have to check to see if another triangle exists, okay? So when you're applying the law of sines and you're dealing with side-side angle, it's a little more tricky than your typical triangle, okay? So again, I have the law of sines written right here, and I just want to show you what happens when you have side-side angle. So we have a new page, and I'm just going to go ahead and draw out a triangle, ABC. So I'll say A, B, and C. So if you have a triangle that is side-side angle, meaning you're given a side, and then you're given an angle, okay? There's the possibility that you could have two triangles here. And you could have two triangles because this angle right here, in our case here, angle C, could possibly be acute or it could be obtuse, meaning it could be less than 90 degrees or it could be greater than 90 degrees. And an easy way to visualize it is picture this right here, this angle B, being like a hinge. And you could swing this leg here to the left-hand side. So for example, I could redraw the triangle the following way. I could make that angle obtuse like this, okay? And notice that this angle A will not be changing, okay? And again, we have angle B here and angle C. And so yes, you could draw it in this manner where angle C will now become obtuse. And again, angle B would change as well. But this length right here, BC, is not going to change, and your angle A is not going to change. So all you really have to remember, okay? If you have a triangle that is side-side angle, at the very end, you have to check to see if there's going to be another triangle, okay? Also, keep in mind, when you're dealing with side-side angle, there are three possibilities. You could have no triangles, you could have one triangle, or you could have two triangles. And we're going to cover all three scenarios in this video. So why don't we go ahead and take a look at our first example. So here's our first example, and they give us triangle CAB and all of its information. So what I'm going to do is draw out the triangle, okay? Now here's my recommendation to you. Whenever you're given side-side angle, you always want to draw it in this orientation here, where the angle that you're provided, in this case here, 67 degrees, goes right here, okay? And then everything else will fall into place. So if this is going to be angle C, this right here has to be side C, meaning it's going to be 35, okay? And that means that side B will naturally be right here, okay? So I'll put 38 right here. And this is going to be the angle in question, okay? And so in our case here, that's going to be angle B, right? Because it's opposite from side B. So again, angle B, and then this will be angle A, okay? So you're actually going to solve this triangle just like you normally would. You're going to do the law of sines, you're going to get all of your information, and then at the end, you're going to check for a second triangle, okay? So let's go ahead and use the law of sines to get all of the missing parts. So first, I have this ratio right here, right? It's a known ratio. I have 67, and then opposite to that, I have 35. So I could write here sine of 67 degrees all over 35, okay? Equal to, from here, I could get angle B. I could say sine of angle B, right, all over 38. And so from here, I can solve for angle B. So I'm going to go ahead and plug this into my calculator, and I'm going to get angle B, right? So I'm going to go ahead and do that right now. Make sure you're in degrees when you do this. So you're going to do sine of 67 degrees. You're going to divide by 35, okay? Then you're going to multiply by 38, so times 38, and you'll get an answer, right? So you'll have the following. You'll have an answer, okay, equal to sine B. But you're not done yet because you have to take inverse sine. You have to get angle B. So in your calculator, you're going to go ahead and hit second and then sine. That will give you inverse sine. And then you go ahead and plug in your value that you got from your previous operation. I'll just plug in A and S. That will take care of it for me. So when I do that, I get 88.02. Okay, so angle B is going to be 88.02. So I'm going to go ahead and just get rid of this here. And I'm going to put angle B is equal to 88.02. Now I'm going to call it B1, okay? Because there may be a second triangle here. So angle B1 is 88.02. 0.02. Okay, and again, that is going to be degrees. Now to get angle A, that's very easy. We just start at 180 and we subtract our known angles. We have 67 degrees and I have this angle that I just found here. So I can say angle A1 is equal to 180 minus 67 minus the angle that we just got. And I get 24.98. So I'm going to put here 24.98. Okay, and that is going to be degrees. All right, what else are we missing? Well, we're just missing side A and then we'll be done. So to get side A, I'm going to use that same ratio we did at the beginning. I'm going to do sine of 67 degrees all over 35 equal to, now we have angle A now, it's 24.98. So I'm going to put sine of 24.98 degrees all over side A. And now all we have to do is solve for side A. So in your calculator, you're going to do sine of 67 degrees, divide by 35, okay? And then you'll get your answer. From here, plug in sine of 24.98 degrees, right? And now you're going to divide by your previous answer. If you have to write this out to do it, you can, but you should be able to plug this into your calculator without an issue, all right? So when I do that, I get the following. I get 16.06. So A is equal to 16.06, okay? So I have this information here that I'm going to box in, right? And I also have this side down here. So I have 3 missing parts and that completes all of the missing parts of the triangle. At this point here though, you're not done. You have to check for a second triangle. And to do that, it's really simple. You're going to look at the angle in question, which is going to be angle B. This is why we put it in this orientation where we have side, side, angle, because the angle in question will never change if you always put it in this orientation. So again, my recommendation, make sure you're always putting it in this orientation that we have here. That way you know what angle you're dealing with, okay, when it comes to checking for a second triangle. So we have to look at angle B and we have to see if we can fit in another triangle. So to do that, it's very simple. You're going to do 180, so 180 degrees, minus what angle B is. That's 88.02 degrees. What do we get there? So in my calculator, when I do that, 180 minus 88.02, I get 91.98. So 91.98 degrees. So this right here is the obtuse version. We have the acute version right now, right? If you look at angle B1, this is the possible obtuse version. Now, do we have room? Well, remember, this 67 degrees is not going to change. I showed that to you at the beginning. So all you have to do to check for a second triangle, you're going to do 91.98 in your calculator, and then you're going to add 67. So plus 67, and I get 158.98. So 158.98 degrees, and that means there's going to be a second triangle because I do not go over 180. Okay, I don't go over 180. Now, if this number right here went over 180, that means it's not possible to have a second triangle. But in this scenario here, I'm below 180, meaning I still have room for a second triangle. So I have to go ahead and do the law of sines again to get all of the new missing parts. So for example, we're going to go ahead and do that right now. I'm going to go ahead and divide this up because we're going to start a new section here. All right. Now remember, angle C is not going to be changing, so we don't have to find that. What we do need to find is angle B and angle A and also side A. So we have angle B right here. It's 91.98. So I'm just going to put angle B2, right, is equal to 91.98. Okay. And so if this is what angle B2 is, 91.98, and 67 degrees is not changing, that means angle A2 is very simple. All I have to do is do 180 and subtract 91.98 and 67, and I'll get it. So when I do that, I get the following. So angle A2 is going to be equal to 180 minus 91.98 minus 67. I get 21.02, so 21.02 degrees, okay? From here, we just have to get side A, and I can use that same ratio that I used in the beginning because remember, this angle and this side are not going to be changing, okay? So I can say here sine of 67 degrees all over 35 is going to be equal to sine of angle A, which is 21.02. So 21.02 degrees all over side A, okay? We're going to go ahead and plug this into our calculator and we'll get side A. So I'm going to put here A is equal to, and again, it is a 2. So I'm going to go ahead and put A2 there, right? So plugging it into our calculator, we get sine of 67 degrees divided by 35, right? We get an answer. And then we do sine of 21.02, and then we divide by that previous answer. So dividing by that previous answer, I get the following, which is 13.64. So 13.64, there it is. We're done. All right, so I have this up here, and I have this down here. So there's the other triangle. So this problem actually had 2 triangles, okay? And again, it's very easy to check. You just take 180 and you subtract the angle in question to see if there's going to be room, okay? Let's try another example. So here's our next example. We have triangle RST. So again, I'm going to put this in the same orientation that I showed you at the beginning. So I'm going to say here, angle R right here, and that's going to be 112 degrees, okay? That means this has to be side R, which is 38.9, okay? And as a result, this will be side T, which is 34. Okay, so again, this will be angle T, and this will be angle S, okay? There's all of our information. Now all we have to do is solve it just like we would using the law of sines and then check at the end, okay? So the ratio I'm going to use here is sine of 112 degrees all over 38.9, okay? I'm going to set that equal to sine T all over 34. So again, we're solving for that angle T right now. So in your calculator, you're going to do sine of 112. You're then going to divide by 38.9, okay? And then you're going to multiply by 34. And then finally, you take inverse sine of that answer. So taking inverse sine of that answer, we get the following, 54.13. So angle T is equal to 54.13. And again, that is degrees. Now to get angle S, that's very easy. We just have to take 180 and subtract our known angles. So angle S is equal to 180 minus 112 minus 54.13. When you do that, you should get 13.87. So 13.87, again, degrees. From here, we just have to get side S. I'm going to use the same ratio that I used at the beginning, right? So I'm going to say here sine of 112 degrees all over 38.9 equal to sine of 13.87 degrees. So sine of 13.87 degrees all over side S. That's what we're trying to find, okay? So in your calculator, you're going to do sine of 112 divided by 38.9, okay? We get our answer. Then in our calculator, we're going to do sine of 13.87, okay? And we're going to divide by our previous answer, right? So dividing by the previous answer, we get the following. I get 10.06. So side S is equal to 10.06. And again, I should technically label these with a subscript of 1 because I don't know if the second triangle is going to exist. So for example, angle T1, angle S1, and then side S1, okay? So these are done. I'm going to go ahead and box those in. And from here, we have to check for a second triangle. So what angle is the angle in question? Well, that's going to be angle T, right? So we're going to do 180, okay, minus angle T, which is 54.13. And again, these are degrees. When you do that, you get the following. So 180 minus 54.13, I get 125.87. So 125.87 degrees, okay? Now I can already tell there's no way there can be a second triangle because remember, angle R is not going to be changing. So from here, you would take this angle that you just found, right, the new angle for angle T, and you would add 112 to it. And that's going to be well above 180 degrees, meaning there is no second triangle here. This is it. There's only one triangle, okay? All right, let's try one more example. So here's our next example. So the two scenarios that we've covered so far, one triangle, two triangles. So you can probably guess what this one's going to be, right? Probably going to be no triangle, but let's go through the problem so we can see how it works out. So we have triangle KHP. So I'm going to go ahead and draw that out. And again, the same orientation as always. That's very important. So this will be angle K. That's going to be 57 degrees. And then opposite to that will be side K, so 7. And this will naturally be 31, right? Side P. So this has to be angle P, and this has to be angle H. So from here, we're going to do the same thing. We're going to solve using the law of sines and see what happens. So I'm going to do sine of 57 degrees all over 7 equal to sine of angle P all over 31. Okay? So we're going to plug it into our calculator and we get the following. We get sine of 57 degrees divided by 7. We then have to multiply by 31. Okay? And when I do this, I get an irrational number. I'm just going to round it. I get 3.71. And I'm writing it out because I want to show you what's going to happen here. And then I have this equal to sine of angle P. We now know that we have to take inverse sine to get angle P. So angle P is going to be equal to inverse sine of 3.71. Now, if you know anything about inverse sine, you know that this is not going to be part of the domain. Our domain on inverse sine, meaning our input, right, our x values, has to be in between 1 and -1, okay? This will not work here, okay? So I know that it's going to be undefined. And if you try to plug this into your calculator, you're going to get an answer that says error domain. And essentially that's telling you that, hey, this number is not part of the domain of inverse sine. And as a result, there is no triangle here, right? So this problem here is no triangle. These are easy, okay? So no triangle. All right, and that is it. So that is how you do the law of sines when you're dealing with an ambiguous case, or in other words, side-side angle. It's pretty straightforward. Just remember, you have to check for that second triangle and make sure you're drawing it in the orientation that I showed you. That way, when you go to check, it's always the same angle that you're using over and over again, okay? So that's going to do it for this video. I hope that you learned something from it. I hope that you gained something from it. If the video did in fact help you, if you could just go ahead and give it a thumbs up, that would be greatly appreciated. Also, make sure you subscribe to this channel. That way you get more math videos in the future, and I'll see you in the next one.